Alright, let's take one last look at polynomials with larger exponents. And this time we're going to do an application problem. We're actually going to find out what these are good for. Well, one thing we can use a large polynomial for is to estimate the age of a dog when we take its dog years and find the equivalent in human years. And here's a function that can model that. It's a nice big long function. To the third power is the leading term. And we're going to read carefully and find out how we're going to use this function. A dog's lifespan is typically much shorter than that of a human. The cubic function d of x equals 1/100th times x cubed minus 34 100ths times x squared plus 7 4/10 x plus 6 6/10, where x is the dog's age in years, approximates the equivalent human age in years. Estimate the equivalent human age for dogs that are 3, 12, and 16 years old. Alright, when you come across an application problem like this, you need to determine two things. You need to determine what the input stands for in the story. Alright? And it will tell you straight out usually, where x is the dog's age in dog years. So write yourself a note. X is age in dog years. Alright, and you're going to use that. This is going to calculate the human age. So d of x is human age, the equivalent human age. So if you can identify those two things, these problems are usually very easy. And I'll let you in on a little secret. When working with these really large polynomials, you're not going to be asked to solve for the unknown on this side of the equation. You're not going to be asked to find x when you know d of x. It's almost always going to be the other way around. You're going to be given a value to put in for x, and you're going to plug and chug with your calculator and calculate the output. So these are actually very easy. They are just calculator problems. So we're being asked to find the age of the dog in human years when it's 3 dog years old. So all you need to do is find d of 3. Okay, remember this side's just a placeholder. We're going to get the output when we put 3 in for each x. So let's go ahead and write that out. We're putting a 3 where that first x is. Subtract 34 100ths, and there's another x coming up. Put a 3 in there, and then plus 7.4 times this x. Put a 3 there, and then plus 6.6. And then it's just a matter of grabbing your calculator and plug and chug. So let's do it. 0.01 parentheses. Use those parentheses to be safe. And we're raising that to the third power. Minus 0.34, another set of parentheses for the 3. And we're squaring that one. Plus 7.4, another pair of parentheses to times by 3, and then plus 6.6. And you should have gotten 26.01. So d of 3 equals 26.01. And let's remember what that is. You put in a dog age and you got out a human age. So a dog that's 3 years old is approximately 26 human years. Alright, I'd like you to go ahead and use this function to calculate 12-year-old dog, what it is in human years, putting 12 in for each of the x's, and then go ahead and do it also with 16 years, and then come back and check your answers.